Welcome back to another video on my channel, math_exe. Today we're going to look at a tricky question that involves integrals when it deals with some linear functions. So this problem requires integrals, specifically definite integrals. So it says find the positive value of a such that the area bounded by the line y equals 2x plus 1, the x-axis, the y-axis, and the line x equals a is 20. So I'll just draw a xy plane just to picture this in your mind. So the graph y equals 2x plus 1 is something like this. And the line x equals a is somewhere right here, marked in green. And then it's bounded between the x-axis, the y-axis, and then the two lines right here. So this area, shaded in red, must be equal to 20, specifically 20 units squared. So we can adjust the position of this line x equals a, possibly right here, to change the area. And then we need to find the positive value of this such that the shaded area in red must be equal to 20. And the first thing you might notice that this area is bounded under a function, and the function is y equals to x plus 1. So what that means is that we can set up a definite integral and then solve for a from that. So I have the integral of the function y equals 2x plus 1. So I'm just going to write that in parentheses. And then dx. And then what our lower and upper bounds will be. It will be 0 and a. Because we start up our area at x equals 0, which is the y-axis. And then our upper bound will be just x equals a, so that it will be x equals 0 and then x equals a. And remember, this must be equal to 20 as told in the question above. Now with this we can just find the antiderivative of the inside function right here, and that's simply just the sum of the antiderivatives of each term. So the antiderivative of 2x will be just x squared using the reverse power rule, and then the antiderivative of 1 will be just x. And then we're evaluating this from 0 to a. This is equal to 20. And note we don't put plus c because we're dealing with definite integrals. So evaluating this at each interval, we'll get a squared plus a minus 0 squared plus 0, which is just 0. So I'll just erase this part. And this is equal to 20. And notice this looks like a quadratic equation, and in fact it is after you subtract 20 from both sides. So you can just either use the quadratic formula, completing the square, or try to factor this. Quadratic equation, and what you'll get is there are two values, so there's a equals positive 4 and a equals negative 5. However, we're just going to reject a equals negative 5 since the question says we're only going to deal with positive values of a. So therefore, the final answer for this is a is equal to 4. And in fact, if you draw this diagram in the XY plane or a sheet of graph paper, and notice this is a trapezium, and then you can just find its side lengths and its height, and then you can just quickly notice that this area bounded under these lines will be 20. Alright, so I'm just going to tell you that this video has two parts. This is the first part, and the second part will also deal with integrals as well. So yeah, let's jump into the next one. Alright, so this is the second part of this video. So we need to find all possible values of t such that the sine area under the line y equals 2x minus 5 from x equals 0 to x equals t is 0. So here's a diagram for configuration. So we have our line y equals 2x minus 5 sloping upwards like so. And then we have this area bounded from x equals 0, which is just the y-axis, and x equals t, which we're going to find the value of t of this equation, of this diagram. Alright, and notice this again looks like a area bounded under a function. So we can just set up a definite integral for that. So if the integral from our lower and upper bounds will be 0 and t respectively, and just we're going to look at from in the x world, and then we have our actual function, which is 2x minus 5, and then we're looking at the x world, so we're going to put dx, and keep in mind this must be equal to 0. Alright, with this we can just find the antiderivative of the inner function, which is just the antiderivative of each term respectively, and then subtracted from one to the other. So the antiderivative of 2x will be just x squared, antiderivative of negative 5 will be negative 5x, so this will be x squared minus 5x, evaluated from 0 to t. This is equal to 0. From here we can just substitute and 0 and our lower and upper bounds, which is 0 and t, and then subtracting them after that. So we're going to have t squared minus 5t minus 0 squared minus 5 times 0, which is just in whole 0. So I'm not just going to write that down, which is equal to 0, and I'm just going to remove these brackets right here. And notice we can just factor a t out of this expression. So with t times t minus 5 equals 0. And from this we have two solutions, which is t equals 0 and I would say or t equals 5. So these are the two only possible solutions for this. And when you look back at the question, if t equals 0, the area bounded under the line y equals to x minus 5 from x equals 0 to x equals 0, which is just 0 because it doesn't contain area at all. And then when you look at t equals 5 in this case, notice we have two triangles, one with negative area since it's under the x-axis, and then one with positive area. And for this to be equal to 0, these two areas, the absolute value of these two areas must be equal to each other. So when you calculate this, you can just measure the base and the height of each triangle of this, and then notice that they'll be the same. And then if you're looking at sine area, these two triangles will cancel each other out, and therefore we have 0 sine area. Alright, and that's it for today's video. So hopefully you guys enjoyed this video, and goodbye.